Righty, welcome back, ladies and gentlemen, to another very interesting topic in our programming course. And this topic is called recursions. So maybe some of you heard of this scary terminology during different lectures in school or college or university. I don't know. It doesn't really matter because together we are going to study and to learn it from scratch, and we are going to solve plenty of examples to make sure that this concept is clear to us and that we are ready to solve different exercises on our own. Okay, so no worries about it, guys. What I want to ask you is very simple thing, okay? I want you to stay calm. I want you to relax. I want you to take 3 breaths, okay? So take a deep breath and breathe it out, and do this 2 more times. So in and out, and once again, in and out, okay? Because this can really be intimidating, and I don't want you to panic. It's going to be all right. So get yourself ready and let's start our journey with the recursions concept. Let's go. So first of all, what is a recursion? Okay, so what is a recursion? First, basically, a recursion is just a concept, okay? It is not some sort of a variable, and it's not some data structure. It simply is a concept. Think of it as a new approach or a new way to solve different problems or different questions. In most cases, this will be done also in fewer lines of code. Okay, so this is just a method for solving problems, okay, a new method. And as simple as it may sound, the idea of recursion is not so easy to understand at first, since it's not common for our minds. So that's exactly why I've decided to take some time and to think about and trying to figure out how can I teach you guys this topic in such a way that you will not have to cry or break anything during the process. And I think I found some way to how I can make some visualizations and general explanations so that now it will be much easier for you and much more fun for you to learn recursions. Okay, so I've also been a student once, and this process and this concept was not the easiest one, and I don't want you to have here a lot of hard time, because I really think that things are not so complicated if they are being taught right. Okay, so let's go. Let us proceed. And okay, so we said that it's not common for our minds, but basically all of that is kind of nice, but how to think about it? I want you to start with a simple example. Suppose we've got some problem, let's call it, I don't know, the original problem, some question or problem that we simply want to solve. For example, we want to find the sum of all integer numbers from 1 up to some given n, okay? So if n, for example, is 5, okay, if n equals to 5, then we are looking to find the sum of all numbers starting from 1, okay, up to a given n, which is currently in this example is just 5. And that means that we need to calculate the sum of 1 plus 2 plus 3 plus 4 plus 5, which will give us a total of 15, correct? And now let's consider and think of this problem, okay, because currently this problem can be also called as the original problem or the main problem. and call it as sum up to 5, okay? That's the naming for this problem, okay? We'll simply name it as sum up to 5, sum all integer numbers from 1 up to 5, okay? Is that clear so far? So in order to solve the sum up to 5 problem, which is the original problem, the bigger problem, in order to calculate all the numbers from 1 up to 5, we are basically going to sum up 1 and 2, okay? And then take the sum of them, which is 3, and sum it up with the number 3, which will give us a total of 6. And then once again, we will take the sum so far, okay, the sum that we have so far, and add to it 4, okay, which will be a total of 10. So we know that the sum of all the numbers between 1 up to 4 will give us a total of 10. And then we will add 5 and we will get the total of 5, which is the sum of all integer numbers from 1 up to 5. Okay, so that's probably how most of us would have solved this question in their mind. Okay, so let me just show you this once again. Where is this pen? Let me get it like blue and let's get the pen done. Okay, so that's basically, oops, come again. So there is the pen. So that's basically sum up to 1, okay? So I will call it, I don't know, S for 1. And that's the sum up to 2, right? So S up to 2. And that's the sum up to 3. So if you've noticed, like in this example right here, that basically what happened here is that what was done is that we simply divided the main problem, which is sum up to 5, the bigger problem, into solving some smaller sub-problems. Okay, so first of all, we found out what is the sum of sum up to 1. And then we used this result to find the sum up to 2, which simply was like take the sum up to 1 and add 2. And then we found out the sum up to 3, which simply relied on the fact that we have to take the sum up to 2, which is this fraction, and add 3 to it. Okay, so simply dividing the main problem of sum up to 5 into some smaller sub-problems. Okay, so that's how we did it. Now we will try to think of a way to divide these original problems into some smaller problems. Okay, and that's basically the whole new method of thinking. Okay, let me show you in more depth exactly what I mean. Basically, that's the point where most of the students get stuck, okay, while they are studying recursion. So please concentrate very much on what I'm about to say right now, because it has a crucial influence on your understanding of this topic from beginner's level to the expert level. So we have to think about the following question, okay, when working with recursions. Can we solve the original problem, the bigger problem, if we would have divided and solved some smaller sub-problems, okay? And if we can we do it on some regular basis? I mean, if we can divide our original problem into some smaller sub-problems, and these smaller sub-problems into further sub-problems and so on, and based on the result of each of the sub-problems, it will simply help us to conclude and construct the result for the bigger problem, okay? So if we can do it, that means we can use a recursion as a solution. So we will take some problem and start dividing it into smaller and smaller sub-problems. And if we could do this division thing until a sub-problem gets to the point where the solution can be found kind of trivially, okay, if we have trivial solution, then if we reach to this point, we can start building our way up and conclude different conclusions and different calculations results that will help us with finding the result for the original problem. Okay, Don't worry, guys, we will soon see some examples and everything will become more clear to you, okay? I'm just trying to build our way up and make sure that none of you will will basically have difficulties here, okay? So just one note for what I mean when I'm saying trivial solution is that basically trivial or straightforward solution simply means that some bigger problem was divided, okay, into some smaller problems, and these smaller sub-problems were divided, so on and so forth, and basically it has come to a point where this some sub-problem, okay, it's so trivial that the solution is like, I can give you the answer right away, okay? So, for example, sum up to 1 from 1, you know that it's so trivial that the result is 1. But sum up to 5 or sum up to 10 is not so trivial. You have to make some calculations, and it's a process, okay, that can be divided to some smaller sub-problems. Awesome. So these were the main things for understanding recursion. It is simply a process of dividing our problem into sub-problems, and these sub-problems into sub-sub-problems, and so on, until we reach some terminating, mostly trivial condition. So we can say that a recursion can be used whenever a problem can be solved by dividing it into smaller problems and repeating some similar process for the smaller problems. And now let us see a couple of cool real-life examples that demonstrate, at least in somewhat, the usage of recursions. Although that's not proper programming, it's also nice to take a look at it. So first of all, let's talk about the Russian doll. Okay, so who is not familiar with the Russian doll? That's a classic example to recursions. You simply have the bigger doll, okay, and if you want to find out how many sub-dolls, how many smaller dolls there are within it, you simply start to unpack to smaller dolls, okay, to smaller sub-problems. And this is done until you reach some point where you cannot divide the Russian doll anymore, which is basically considered to be the trivial solution. So that's example number 1, okay? So we have the bigger problem and we also have some smaller problems until we reach some trivial solution where we cannot divide it any further, and we know that, okay, now we have like 1 and let's build our way up, okay? And a second option is like a dream inside a dream. You know, the times when you dream a dream, where you dream a dream, where you dream a dream, and so on, in some recursive manner. Okay, so that's also kind of of an example. Also, we have like counting folders in a computer. Okay, so there is a folder inside a folder inside a folder until you reach some folders that don't have any subfolders inside of them. Also, something that you can also try is simply writing down recursion in Google. Okay, so write down recursion. Okay, my bad here, I forgot to add these parentheses here. Parentheses, I'm saying. Basically, go to Google and type down recursion, a link that opens the same page over and over. That's what you're going to see. It's a cool feature of Google, at least for the moment that I record this video. And there is a lot of other interesting problems that remind us of the recursion concept. But for now, simply remember the main idea, the main understanding of recursions, that it has a bigger problem. This bigger problem can be divided into smaller problems. And basically when you divide it into smaller problems, there is, or at least there should be, some stopping conditions, some trivial solution that from this point on, this mechanism should stop making these calls for the division of subproblems, and it should basically build its way up and build the result for the final problem based on the results of the subproblems. So that's about the theory, and now I think we can take a look at a couple of examples and to see how they will look like when we are going to work with practical examples and code. So I hope you are ready, guys, because here we go.